Hey friends, Miss Paraso here to talk to you about compounding interest. All right, if you've had me in class, then you've already had and watched a video about how this all works. So today we're just going to be taking a look at the formula and all the different pieces. All right, so just to do a side-by-side comparison, the compounding interest formula is really just a growth formula. Okay, that was our exponential growth formula. The only difference is right there, right? Because time, T is time in years, and with interest, you can get it monthly, you can get it quarterly, so you can get it at different frequencies throughout the year if you want. So we need to account for that, because if we're getting it quarterly, then we'd want to go, okay, well, how many quarters are there in a year? There's 4, and if we do that for 10 years, we want to go ahead and adjust that rate. All right. So again, let's say we get 20% interest, which if you find someone that does that, snag that up. But if it was 20% interest quarterly, then we want to split that up over 4 times. So that's where we're going to split that rate over the year. So let's go ahead and take a look at how this looks in the first 2 example problems. All right. So it's really just about going through and identifying what pieces do we know, what do we have, and what is it that we are looking to find. So as I'm reading, I see here I've got a $500 investment. So that means that's where I'm starting. That means that's going to be my A value. Okay, because the A is your initial amount, where you're starting, typically called as your principal. Okay, then I see here it says it pays 5.5%. Okay, 5.5%, that's my rate. But we want to turn that into a decimal, and to do so, just divide by 100. Means that you're getting rid of that. Okay, so remember to move it over 2 places, and I think I moved it over too far. Yep, there you go. All right, and don't drop anything that's not a 0. Now the other part is that it's monthly. Okay, that's that N value, the number of times that we're doing that in a year. So because it's monthly, that means that our N value is going to be 12. All right, and then the last thing that we want to do is, all right, well, we want to know what is the value going to be after 6 years. Okay, that's going to tell me that's how long I'm letting this investment grow. Okay, again, this is not taken into account if you add anything to it. It's just saying, hey, we put in $500. What would I expect to have in 6 years? So we're going to go ahead and start with our formula. We got y equals, and instead of A, we're going to go ahead and plug that in, not plus, times 1 plus 0.055 divided by 12, because we're going to split that rate up monthly. And we do that 12 times for 6 years. So that's your setup. Like, that's what you should be showing, right? Don't just automatically jump to your calculator, because if you type in something wrong or something along those lines, we're not going to be able to backtrack and kind of see where that information, what happened with that information. All right. So my next step for this would be to go ahead and in my calculator, I'm going to go ahead and do this piece right here, the 0.055. I'm not sure if my cursor is showing up. I'll use this mouse. Maybe that circles it a bit better. All right, so in my calculator, I'm going to go ahead and do 0.055 divided by 12. And again, I just want to show you where all of my numbers are coming from. Okay. And I'll go out that far. I'm not, I think we can talk about where should we round to and things like that moving forward. So it kind of depends if I'm not your teacher or something, you're just watching this video, you might want to just follow up with them. And then 12 times 6 is 72. Okay. So this essentially just becomes, let me go ahead and add those together, is 1 point. I'll just put that times there. 1.00458. Okay, and so now I can go ahead and put that into my calculator, and let's do that. 1.00458 to the 72nd power, and we're going to go ahead, and so when I did that, I got 1.3895. I'm going to leave that in my calculator. I'm just going to do this all at once, times 500. Okay, and so again, I'm going to write down, I like to go out to 3 or 4 decimal places, and then I decide where my rounding is going to go, and so it keeps going like that. But again, because we're talking about money, we're going to go ahead and round to the nearest penny, all right, which is right here. And we can see that we would expect to see $694.79 in 6 years. So almost, almost $200 after 6 years, and that's without adding anything to it. Okay. And now, again, depending on where you rounded this number inside those parentheses to, you might have gotten a slightly different answer than what I got. And also, maybe you estimated whatever this is. Maybe you said it was just 1.39, and then you times it by 500. So that's why it's super important to make sure you're showing what you are inputting into your calculator, so that way if we're off by a few cents or whatnot, we can understand why. Like, is it just because of where we did our rounding, or is it that we messed up which numbers to put in? All right, we're going to go ahead and do one more example here. And I think I'm going to go ahead and let's go ahead and take a look at, let's see which one's a little bit different. Let's go ahead and take a look at number 4. Okay, so we'll go right underneath there. All right, I like this one because this one, we're going to take a look at it and see how it differs from that first one that we just did. Okay, so I'm going to write my formula off to the side just so we can always see that. Okay, all right, so as we're reading, it says a sum of money is placed into a savings account. Well, my first question already is like, well, what is that sum? So I'm going to go ahead. So something was that we started with something, I just don't know what it was. And it says with a fixed annual interest rate of 4.61%. Okay, 4.61%. And it's compounded 3 times per year. All right, so that tells me that other piece of information. All right, let's see. After 6 years, so in 6 years, this is how much money was in there. All right, the question is, what is the initial amount? And that's what I highlighted in yellow up there. So that's my A value that I'm looking for. So this is my A. Again, if it's asking for the initial, it's asking for that A value. Here's my rate. I'm going to go ahead and turn that into, excuse me, into a decimal. I know this is my N value is 3, and here is my T value is 6. Now, this number right here, remember these two kind of go together, this T and this Y, because after this many years, I'm going to do all this calculation and I'm going to get an output. So I know that after 6 years, this is what's going to get produced. So that's actually my Y value. So I can go ahead and start filling that in. $5,485.85 is equal to something times, all right, we're going to add. All right, so I'm going to go ahead and put this in. I'm not going to do any math just yet. I'm just going to fill in everything I know, and it's compounded 3 times per year. So, and we did this for 6 years. Okay, so all I did was replace everything. Now I'm going to go ahead and clean this up a little bit so that way I can start solving for it. All right, so we have A times. All right, so inside parentheses here, again, I could go ahead and put this into my calculator exactly how it is, but I like to show at least what the inside the parentheses simplifies to, because we're going to probably do some rounding there. Let's just see. Okay, yep. So I get it's 1.015, and I'm going to round it to 4. It's 5.3, and then the 6's repeat. So I'm going to do this. All right. So if I'm trying to get my A value all by itself, that means that I need to get rid of this right here. Now, for precision's sake, I'm not going to go ahead and calculate this. Again, this is kind of a preference thing. I want to get this precise as I can with that number. So that's where I'm going to go ahead and I'm going to divide out. I'm not going to calculate it just yet. I'm actually just going to divide both sides So I'm going to take that $5,485.85 and divide it by that exponential expression. That way it's going to cleanly cancel out. I'm not really worrying about doing any more estimating there. So let's go ahead and plug that into my calculator. 5,000, make sure I got the right number in there, yep. Okay, divided by 1.0154 to the 18th. All right, and we enter that. Okay, and for me here, when I do it that way, I get 4,166 and 0.5352 dot, 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 dot. All right, so we're going to go ahead and round that to $4,166.54. Now, just to show you on the calculator here, right? Here's how I put that in. Let's say that I took this number up here, right? Let's go back and let's say I rounded in a different spot, right? So let's say I did 1 instead of, right, this was what was inside my parentheses right here, 1 plus 0.046, split it up. All right, so let's say I did 1.015, right? 1.015, and I'm going to go ahead and put it to the 18th power. Okay, and I get 1.31. Okay, or maybe I did it as 1.0154 to the 18th power, and then I estimated there, right? I get 1.32, right? So it might not seem like a big difference, but when you're dividing and with multiplying and dividing and exponents and stuff like that, the bigger and bigger the number you get, right, it's going to make this a greater difference. So it's not going to be off by just 100th now. So this is what I'm talking about, is like, that's why you want to really be clear in your work about what numbers are you using. Oops. Okay. Oh, didn't even know that was a thing I could push. Okay. So what numbers are you using to take care of that? And I don't know how to now get out of that. Oh, there, exit drawing. Okay. All right. So let me go ahead and move my calculator back over. All right. So that means that, just again, what I'm trying to say is, let's say I took 5,485.85, and instead of dividing by this number, I decided to divide it by the estimate, which was 1.32. Okay. And so if I did that, 5,485 and 85 cents divided by 1.32. Okay. I then get 4,155 and 94, about 95 cents. So, I mean, almost $11 off. So it's really essential. Like, again, it's not too far off, but it's not just like a penny or two. It's not just the thousandths or the hundredths or, you know, a tenth off. We're now into, you know, the whole numbers being off. And so just make sure that you are communicating what you are entering into your calculator, so that way it's very clear about why you got the value that you got. Because when it gets to exponential and things like this, these numbers are not going to be nice, neat, and pretty. And we want to make sure that we understand why we're getting those values. All right. Hopefully that helps kind of break down the process about how to use the formula, how to best show your work with these types of compound interest problems. Have a great day.